Hey, it's Brandon Lundmark and Clint Hamilton here to teach you guys how combustion engines work. This was part of our final design project for our Engineering 1332 SolidWorks class at Oklahoma State University. We are both mechanical engineering majors and have always been fascinated with how things work. We take special interest in vehicle and marine engines. At the beginning of the class, we were posed with a task to design a piston engine that demonstrates the combustion process without actually using fluids or combustion. The LEGO group gave us the best preliminary ideas for development of our model. As you can see in this demonstration, the LEGO builder uses similar parts to our final model. We did not want to reinvent the wheel, so we got inspiration from the smaller parts when we turned to SolidWorks for our model development. The design process works in a unique way when using SolidWorks. You can publish a drawing for people to use to replicate your assembly or part, but you have to have an assembly or part before you can make a drawing. These two drawings are a depiction of our final assembly. The first page renders the full model dimensions along with an isometric view and dimensions for the piston and rod. The second page depicts the dimensions for the rest of the parts that make up the assembly: piston holder, crankshaft holder, and engine block. The second page also features a BOM or bill of materials with numbered balloons that depict what each part is. The BOM also features what each part is made out of and how many of each part make up the assembly. So you guys might be wondering how combustion engines actually work. This SolidWorks motion analysis helps paint the picture for you. There are 4 steps to the combustion process of a 4-stroke engine. The first step is intake, where the downward motion of the piston draws in an oxygen and gasoline mixture into the top of the engine block. The second step is compression, where the piston reaches the bottom of its downward motion due to the crankshaft and starts to head back towards the top of the engine block. During this time, the mixture is compressed to the point it ignites and expands powerfully and rapidly, pushing the piston downwards during the third step of power. After the power step, the cylinder is full of exhaust that needs to be expelled before the intake process starts again. This process happens thousands of times a minute for each cylinder, hence RPMs are revolutions per minute. The pistons are offset so that 2 are up while 2 are down at all times. This ensures the pistons are always doing each of the 4 steps. This way the pistons help push each other up and down to keep the motor running. We really enjoyed working through this design process and would love to answer any questions you might have. We want to personally thank you for this opportunity to share our design with young kids and spark their interest in STEM at a young age. Have a great day.